This is 1.2 for Math 20-1, where we deal with arithmetic series. And right off the bat, the only distinction between a sequence and a series, and we're going to look at the same one for this, is if I wrote 1, 2, 3, 4, that's an arithmetic sequence, right? The common difference is 1, there's 4 terms. To make it a series, all we have to do is make sure that we would see that those terms are added together. Now, right off the bat, I would like to identify that in this particular case, there's 4 numbers, so the sum of those 4 terms would be 10. Now, where this becomes more interesting and more useful is what if there's more than 4 terms? What if there's 4,000 terms there? You don't want to have to add those one by one. And legend tells us that Gauss was told when he was in elementary school or maybe grade school, it doesn't really matter, that he was annoying the teacher, and the teacher said, okay, add the numbers 1 to 1,000. Tell me what you get. And supposedly he came back a minute later and had them added. And the way that he did that, or at the very least what we're going to focus on in this instructional video, is how could I do this if there was more numbers? And what I want to show you is that if I took the numbers 1 plus 2 plus 3 plus 4 and I added it to itself. Now what I'm going to do though is I'm going to write the other series backwards. So I'm going to write the other series as 4 plus 3 plus 2 plus 1. What Gauss noticed is that if we write these series backwards, well, 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, and 4 plus 1 is 5. Gauss noticed that when we have an arithmetic series, if we add it to itself in reverse, we get what I like to call the common sum. So this series added onto itself give me 5 plus 5 plus 5 plus 5. Now, because there is 4 terms, we know that this could be written as 4 times 5, right? There's 4 groups of 5 each, and then we can identify that's 20. Now, before you get too upset that these two numbers aren't the same, you have to remember that we added that series to itself. So that's not the sum of one series, that's the sum of 2 of those series. So if I identify that that's 2 times the sum of those 4 numbers, which is equal to 20, if I divide that by 2, I get that the sum of those 4 numbers is 10. Now, this is, I really wanted to illustrate this. I show this in every class because it's important to realize that these formulas don't come from, thin air. They're derived through, somebody probably getting pissed off as a teacher and trying to do it a little bit simpler and a little bit more efficiently. What we have to do is recognize that what this allows us to do is come up with the formula for the sum of n terms in an arithmetic series. And I want to talk about what I did there. If we look at this very first sum right here, I can say that 1 is term 1 and 4 was Tn. Now, I'm putting Tn there because we don't always know if it's the 4th term, the 40th term, or the 50th term. So the sum of those n terms, what we did is I took the first term and I added it to the last term, whatever that last term would be. And then what I did is I multiplied it by the number of terms, which was n. Really importantly though, there's this last step right here, I divided it by 2 as well. Now this formula, and my Sn got a little bit wild there, but I'm going to put Sn is equal to n over 2 times term 1 plus term n. This will allow us to find the sum of any arithmetic series. There's a little bit of a condition there though. We have to know what the last term is, that's Tn. We have to know what the first term is, and we have to know how many terms we're adding. We spent, and it's a while ago, well, hopefully not too long ago, we spent some time in 1.1 talking about how Tn in any arithmetic series, or sequence for that matter, is term 1 plus n minus 1 times the common difference. Well, what that allows us to do then is I can put that into the other equation. And if I combine these two equations, I get, and it's going to be, we're going to do a little bit of algebra here. So S of n is going to be n over 2 times term 1. But instead of Tn, I'm going to put in that term 1 plus n minus 1 times the common difference. Now, we can clean that up quite a bit. When I do, I get that Sn is equal to n over 2 times 2 term 1s plus n minus 1 times the common difference. Now, the way that we use these two formulas, and I'll put asterisks on both of them, is I would use this first formula if I knew the first, the last, and the number of terms. I would use the second formula if I knew the number of terms, the first term, and the common difference. They are both usable in any arithmetic series. It just depends on what the question gives you, and then we can decide on what we'll use. And I'll show you that in this first example, that both of these equations are ultimately interchangeable. It's just you want to use the one where you have the most or the required information, and we'll really be looking for S of n most of the time.